Friends, welcome to video lecture series Renewable Energy Resources. Module 1 Introduction to Energy Resources. Today's class we are going to discuss about the factors affecting the energy resource development. Previous class we discussed this energy scarcity and the solution for the scarcity. Now we are going to discuss what are the factors which is affecting the energy resources development. Here there are 5 factors that make energy resource development more difficult than the normally realized. What are the 5 factors in the sense? Substitution, that is fuel substitution or energy substitution, energy density, power density, intermittency, geographical energy distributions. First, we'll see the energy fuel substitution. Energy substitution or fuel substitution or scale of shift. This is one of the factor which is affecting the energy resource development. Today, there are abundant of energy is available, but we don't have knowledge to convert it, transport it, and we don't have any readily available energy resources. Suppose one energy plant is failure in the sense we cannot be able to use this within second the next plant for the same generation of electricity. Suppose assumption is made here one electric plant is failed in Karnataka in the sense nearly 3 to 4 days is required to go for the alternate source. During the time the power shutdown will happen which will affect the economic growth due to the shutdown of industries. And the domestics are affected. So there is no readily available energy resources that is large enough to substitute for the fossil fuels. Coal energy, coal, oil, gas and nuclear are coming under the fossil fuels. We have a abundant energy system, that solar energy, but we cannot able to convert it into proper energy resources because it requires more space, it requires large infrastructure, installation is very difficult, practical conversion to electricity using photovoltaic cell which requires a large scale of industrial heat are quite negligible. Second factor is energy density. The amount of energy contained in unit of material object is nothing but energy density. That is, how much amount of energy is obtained from the material. If we take one photovoltaic cell in the sense, the smaller cell generates 1 volt. So, whole material will generate 1 volt or 0.5 volt. So, that is nothing but energy density. Agriculture waste, straws, thousands of kilos we are using, but it contains only 12 to 15 megajoules per kg of energy will be obtained. For example, if we take energy density of the good quality coal is twice is very high when compared to the crude oil. Quality of coal, good quality of coal energy density is 25 to 30 megajoules. But crude oil energy density is 40 to 45 megajoules per kg. Then generation of electricity twice when compared to coal. So in order to obtain the equivalent output and replacement of unit of fossil fuels, we need to go for the substitute of solid biofuels. The ratio would be 1.5 times when substituting the plant derived from the ethanol for petrol. These realities would be reflected in the reserve capacity, cost, and operation of the required infrastructure. Third factor is power density. What is power density? It is nothing but the rate of energy production per unit earth area. Rate of energy production per unit earth area. It is normally expressed in watts per square meter. Suppose coal. Coal is occupying more space. But how much energy? The earth is having large number of space. But in that earth, only coal is a small. The rate of energy production per unit earth area is very small. The lengthy period of formation of coal to biomass and from coal to hydrocarbon, it takes lengthy time. Since the fossil fuels are deposits extraordinarily concentrated in the source of high quality energy. Biomass energy production just the density below 1 watts per meter square, while density of the electricity produced by the water and the wind in the sense 10 watts per square meter. If you take the photovoltaic electricity generation, it delivers larger than that 20 watts per meter square. But what is the thing is there in the sense cost and performance are the constraints for the mass utilization. If you go for the mass generation of the electricity using solar and the sense, then cost, some constraints are there. The fourth one is intermittency. Growing demands for the fuels, energy, and electricity fluctuates daily and seasonally in the modern civilization. There is a power shutdown, power failure, fluctuation. So, base load is nothing but it is defined as the minimum energy required to meet out the demand of the day. That is nothing but the base load. But it is increasing every day. The usage is more, so it is increasing every day. The base load demand is increasing. We can store the fossil fuels for the energy, easily storable high energy with the help of fossil stores. And thermal electricity generating stations are also capable of operating the high load factors. But other hand, we have wind, we have solar radiation directly. These are the intermittent resources. As far as practicable, which can deliver very low load to the factors. They can never deliver such high load factors. Annual load factors of the wind generation in countries in the sense 20 to 25 percentage. Unfortunately, still lack of storing of wind and solar energy. The last factor which affect the resources is nothing but geographical nature or geographical energy distribution. Previously, we said that in the solution to the scarcity of the energy crisis, we have discussed there due to the uneven distribution of the fossil fuels and non-fossil fuels such as solar wind. This geographical energy distribution is occurring. Due to the cloudness in the equatorial zone, which will reduce the direct solar radiation. So, some part of the countries, insufficient wind which will not able to generate the energy for from the natural resources. Some of the sites with the best potential for the geothermal, tidal, or ocean conversions. But the energy sources we have to consider for the three things. Three P's are very important going for any kind of energy resources is nothing but whether it is possible or probable or practicable. So if you are going for the sources like a solar light, it is possible. Yes, it is possible. Probable. Yes, it is probable. Practically, it is applicable. Yeah, it is applicable. Solar heat, same. Wind, okay. Water power, you can use it. Fusion, you can use it. Fission, possible, probable, but practically it is difficult. And we have some sources. Geothermal, if we talk about the geothermal, it is practical and probable and possibles. But OTEC, what is OTEC? Ocean thermal conversion, energy conversion. It is possible and probable, but practically it is not applicable. Where it is applicable, wherever you are getting the ocean thermal, that large amount of water which is having the surface of heat, there only it is possible. Thermionic emission. So these are the things we have to see that while you are going for the resource development.